So hello guys, today we are going to do a little question that goes by the name check if a string can break another string. Okay, check if a string can break another string. The question number is 1433 and it's a medium level question. So first what we'll try to do, we'll first try to read the problem statement and then we'll go into the solution. This is what we do here. Okay, this is a regular pattern. First try to understand the question. Sometimes the understanding of the question takes us 10 minutes. This can happen. That's why my videos are so long. Okay, because if you don't understand this problem, you cannot go to the solution. Okay, that is as simple as it looks, as it sounds. Okay, so first we'll try to go into the problem and then we'll eventually go to the solution. So let us try to first read the problem statement. So what you are given? You are given two strings s1 and s2 with the same size. Okay, you are given s1 and s2 with the same size. Okay, check if some permutation of string s1 can break down some permutation of string s2 or vice versa. Okay, so I'm given with string s1 and s2 and what I'm said that check if some permutation of s1 can break s2 or some permutation of s2 can break s1. Okay, or basically or these are the two conditions that can be met, that are to be met. Okay, in other words, s2 can break s1 or vice versa. Okay, so string 1 can break string 2 or string 2 can break string 1. But what does it mean by this break? What is this break? What is this break? Let us try to understand what is this break. Okay, so I am given in the next line that a string x can break string y. Okay, a string x can break string y, both of size n, if x of I is greater than or equal to y of I in alphabetical order for all I between 0 and n minus 1. Okay, what you basically said is like suppose you are given the string abc and axy. Okay, so if you just try to compare, this is string s1, this is s2. Okay, so we just try to compare the characters, this and this character, this and this character, this and this character. So all the characters, like any permutation, any arrangement, basically any arrangement is such that, like, see, if I just consider these characters, a is greater than or equal to a. Okay, this x is greater than or equal to b, and this y is greater than or equal to c. This y is greater than or equal to c. So I mean that basically characters of one string should be greater than the characters of other string. Basically characters of s1 should be greater than or equal to characters of s2, or characters of s2 should be greater than or equal to characters of s1, and I can align any element to any element. Okay, because basically this y can also align with, suppose you are given with this axy, so this x can align with this c, or y can align with this p, or y can align with this c, y can align with this a, as long as it is satisfying the condition. It is all good. Okay, so you can basically, what does I mean by permutation here? Permutation here means like all the possible combinations. Like if you see, what are the permutations of this string? It can be a, b, c, then ab, then ba, then abc, then this string will have 6, like abc, acb, bca, bac, cab, and cba. Okay, so these are the permutations of the string, and this can be bc and then cb. Okay, any other permutation possible? ab, ac, and ca. Okay, so these are the permutations that are possible. So basically any element can be aligned with any element here. Any element, like this can also be done, this can also be done, this can also be used. So any permutation can be used. Okay, this string length 3 will be used here. Why? Because see, like these are all the subsets, all the subsequences of the string, but these subsequences will be valid. Basically abc, bac, cab, cba, then bca, then acb. These will be the valid ones. Because I'm said that it should be having a length 3. Both the strings would be equal, so this should have a length 3. Okay, so these strings are the one to be valid, and if all the combinations being checked, like at this position, at the first position, A, B, C can both all be present. Like if I check for this, at the first position, my A, B, and C can all three be present. At this can also be three my present. This can also be three present. Okay, three possible solutions. Three possible elements are present at each of the position. Each of the position. Okay, like they can be there, right? They can be there. I'm not talking about the total number of combinations. They can be there, right? See, A can be placed here also. So any element can be compared with any element. This is my first observation. This is my first observation. Okay, so I can basically compare any element with any element. So if any element can be compared with any element, like suppose we take the first test case A, B, C, and X, Y, A. Okay, so this has a permutation like A, X, Y, something like that, and this can be A, B, C. Okay, so this A can be compared with A, C will be compared with Y, X can be compared with Y. Okay, so this can be my factor of comparison. This can be my factor of comparison. Okay, this can be my factor of comparison. So this can be my factor of comparison. So every character can be compared with any character. Okay, this Y can be compared with this B, this X can be compared with this A. Okay, so if I can just compare any character with any character, so that means there can be just two possible solutions, like two possible ways to find the solution. Okay, either like see, you have to arrange these elements such that all the elements of S1 are either great, like all the elements of S1 are greater than S2, or all the elements of S2 are greater than equal to S1. Okay, and you can assign them in any order to each of the element. Just this condition should follow. This condition, you have to make this condition to be followed. Okay, so if I check for the first test case, A, B, C, and AXY, basically it was XYA, but I can choose this, or I'll compare this only. Okay, XYA. Okay, so if we just try to see, if I just compare, suppose what are the options of my alignment. Okay, if I just align with this X with this A, okay, this X with this A, then this Y with this B, okay, it is following the condition. Yes, my X is greater than equal to A. Yes. Is my Y greater than equal to B? Yes. But is this A greater than equal to my C? Greater than equal to my C? No, no. So this is where condition fails. No, this is where the condition fails. Okay, so what I have to just see is I have to arrange them such that this rule is maintained. This rule is maintained. Okay, but if I just try to see the same test case and I align this A with A, this X with B, and this Y with C, and this Y with C. Okay, so this will give me my answer because see, X is greater than equal to B, Y is greater than equal to C, and my A is greater than equal to A. So yes, this is following my condition. This is following my conditions. This is following my conditions. Okay. Suppose one more thing where the test case would fail. See. If something like this is given, A, E, and F, A, E, F, G, and you are given with B, C, G, H. Okay. So if you are given with something like this, what is the order that you can have to assign? Suppose basically you assign this D with A. Okay. Okay, then this G should be aligned with G. Okay, this H will be aligned with this F. Okay, so D is greater than equal to A. Okay, I value you. Okay, is this G greater than equal to G? Yes. Is this H greater than equal to F? Yes. I still is true. Okay, so but if is this C greater than equal to E? Is this C greater than equal to E? No, no. So this is where my condition fails. So how can I align them? How can I align them? How can I always find the best alignment? Best alignment. Okay, how can I always find the best alignment? Just see. It's very simple. Very simple. Either you can check for every combination. Either you can check for every combination. Okay, every combination. This is the very brute force approach. Okay, see, basically if you're given with ABC and XYA, so ABC with XYA, you can check with all. Okay, A can be aligned with X, A can be aligned with Y, A can be aligned with A, and then you have to check with this. If you align this A with X, then you will check with B with Y, and then B with C, B with Y, and then B with A, and then you will check for all the cases, like A should be aligned with C, and you will just consider all the cases, and this would result in a recursive solution of exploring all the cases, recursive solution of exploring all the cases. But is it my optimal solution? Is it my optimal solution? Is it my optimal solution? Let us see the constraints. Okay, so my constraints are somewhere about 10 raised to power 5, and if I just try to run this recursive solution, 10 raised to 5 test case, like this test case with the value 10 raised to power 5 elements, is it gonna run? No. Suppose we have time calculator somewhere like n raised to power n, so 10 raised to power 5 raised to power 10 raised to power 5. No, bro, this is not gonna run at any cost. This is not gonna run at any cost. So how can I just align the elements such that they always follow the order? Okay, I'll just make a simple observation. Okay. What elements can I compare? Just try to think like that. What elements can I compare at last? Okay, should I compare, if like you are given with this ABC and you are given with this X, Y, and Z. Okay, so what element should I compare this? And you have to make this S2 greater than S1 condition. S2 greater than S1 condition. Basically, this is my S2 and this is my S1, and you have to make this condition possible. Okay, so what you will see? How can you make this condition possible? Shall I make the greatest element equal to the first element? Will that be a wise choice to make? Because see, you have to follow this condition, right? S2 should be greater than equal to S1. All the characters in S2 should be greater than equal to S1. Okay, and you are given them in sorted order. Okay, you're given them in sorted order like A, B, C, and X, Y, Z. So what would be a wise choice? Is aligning my Z to A would be my wise choice? Like A should be aligned with Z. Is it a wise choice? No. Why no? Just try to see. If you just align the biggest element with the smallest element in this array, with the smallest element in this string, then all the elements that are occurring after it will become smaller, and all the elements occurring after this will become greater. So will this condition be followed? Anytime? No, because if you see, this condition is gonna fail at any sometime, because if it was like this, like B and then A, okay, if it was like something like this, okay, so if you see this, till this point this condition follows, but if it is gonna increase and if it is gonna decrease, so here comes a point when this element would be less than this element, so my A is less than C. Okay, so this is the point where the condition fails. This is the point where my condition fails. Okay, so what would be a wise choice to make? The first thing to notice would be, what if you align biggest elements, biggest characters to the biggest ones, okay, to the biggest ones, and if any time they are not following the condition, you can simply return false. Okay, just see, just compare the bigger ones with the bigger ones. Okay, because see, if you just try to compare this bigger one with the smaller one, then this bigger one, there can be a case that this bigger one is slightly smaller than this. Okay, suppose you are given with 5 and then 6 and then 1 and 2. Okay, so there can be a case, right? Like if 7 is given, 7 is given. Okay, so if you compare this 7 with 6, it is a wise choice to make. Okay, it is a wise choice to make. But is comparing this 2 and 5 a wise choice? No. Okay, let us take the example in case of strings only. Okay, let's see, A, B, C, and then X, Y, A. Okay, what is the biggest element here? Y. And what is the biggest element in this case? C. Okay, So if I just try to compare this C with Y, okay, is this a better choice? Is this a better choice than this, like C align with B, or C align with X, or C align with A? Yes, because if we just align the biggest elements, then all the smaller ones can be aligned together. All the smaller ones can be aligned together, because will not be a possibility there will not be a possibility then that the case doesn't, like, the condition fails. Okay, like ABC is present and then XYA is present. Okay, I just have to make sure that I compare the biggest elements. Okay, I just compare the biggest elements. Okay, because if I don't compare the biggest elements, then the condition is bound to fail. Okay, so how can I get the biggest elements in order? Yes, just sort the strings. Like this is ABC, this is already sorted, and what I was given with, X by A. I can sort it like X AXY. So this is my second string and this is my first string. If I just try to compare this last character and this last character, okay, I'll check for the first case now. Okay, I have like two cases. Either my S1 should be greater than S2, or my S2 should be greater than S1. I'll check for both the cases. I'll check for the first case first, this case first. Okay, so I'll try to move from here, and I have to make this S1 greater than S2. Okay, I'll make two flags. Why? Because I'll just see if any time the condition fails, I can simply exit the loop. And at last, if any of them is true, I can simply return true, or I can return false, Okay. So what I can say is, I'll just compare the C with Y. Is my C greater than or equal to Y? No, no. At the first case only the condition failed. So I'll just exit my loop, and my flag one would become false. Okay, never mind. This is the first case. I'll just try to consider the second test case. Second case, where I'll just iterate from here. I am just now considering this case. Okay, I'll compare this Y with C. Okay, is this Y greater than or equal to C? Yes. Okay, cool. I'll move forward. I'll come to this element. Is my X greater than or equal to B? Yes. I'll simply move forward. Yes, it is following my condition. Is my A greater than or equal to my A? Yes. Yes. So what is my final answer? As this flag 2 was true in the first case, like was true initially when it was declared. So, and the condition is not failing at any time. So it would be true returned. True would be returned. Okay. So what I'm simply doing is, I'm checking for both the cases. I'm checking for both the possible combinations, like S1 should be greater than S2, or S2 should be greater than S2. Okay. These two conditions should be checked. And how can I check them? I can simply sort the strings, and I can traverse from the back. Sort the strings and traverse from the back. Because comparing the biggest elements would be the best choice I can make. Because if I don't compare the biggest elements, then there can be a case like, see, ABC is present. Okay, ABC is present, and you are given with this Y. Like, see, A X and Z is present. Okay, you're given with this Y. Okay, and you are given with this B and C, or you are given with this Z. Okay, so if you just align this Y with A, okay, if you just first try to align this Y with A, these are not, I'll just try to sort it first. Okay, what I'm given with, I'll just try to sort it. This A, then Y, and then Z. Okay, these are my strings. Okay, you said that I will not align the biggest strings with the biggest ones. Okay, so I'll just try to align this A with this Y. Okay, I'll align them. Okay, is my condition following? Yes, it is following. But how, bhaiya? It is following. Why? How? I align this Z with Z. Are they following the condition? Yes. But when I come here, okay, is it still following my condition? Like, is my A greater than or equal to X? No. So there was a case when I could have compared this A and A, and this X and Y, but I chose to just compare compare the non like ordered elements, and this would result me a wrong solution. You can try the test cases, just try the test cases, and you will get soon realize that this is the optimal solution. Okay, I'll just try the second test case. ABE and ACD, ABE and ACD. Okay, this can be my possible solution, S1 greater than S2 or S2 greater than S1. I'll just try to sort them first. Are they sorted? Yes. So what I'll do is I'll simply check for this case. I'll simply check for this case. I'll come at the last element. Is it following my condition? Yes. E is greater than D. Yes. Is B greater than C? Is B greater than C? No, no, no. So my flag 1 would be turned false. Flag 1 would be turned false, and this is the case when I return. This is the case when I return. Okay, my first case is successfully failed. Successfully failed. Okay, I come to my second case. Okay, is my D greater than E? Is my D greater than E? No, no, no. So both the flags are being false. So now what at last what would I return? Yes, F1 or F2. So any of them would be true. I'll simply return true. Okay, I'll just try to do the last test case. Leet and then code. Okay, LEETCODE and then interview. Okay, and then if I just try to rearrange it, CO like CEEEE. Okay, then T, then D, basically CDEEE. L and then T. Okay, and then I, then E, then I, P, R, P, W. Okay, B, W. Okay, so this is my order. Okay, if I just try to compare the elements, like if I given with two cases, S1 greater than S2 or S2 should be greater than S1. Okay, so I'll try it for this test case. This following my condition. Is G greater than W? No, 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 no. So my first case failed successfully. Okay, okay. I'll try for this test case. I'll try for the second one. Is this following my condition? Yes, yes, yes. Okay, I'll try for this. Is it following my condition? Yes. 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 So this would return true. This would return true at last. So what is my optimal solution? What I try to observe? I don't have to observe for all the cases. Just compare the biggest elements. Just compare the biggest ones. Just compare the biggest ones. Just like and iterate to the smallest. And at any time you get this as not following the condition, then you will have to return false. Okay, I'll try to code it for you. Bool flag 1 is equal to true, and then flag 2 is equal to true. Okay, I'll just iterate from the last. I'll just sort them. S1 dot begin and then S1 dot end. Okay, and what I'll try is I'll just have to check for both the cases. I'll check for the case where S1 should be greater than S2. I'll check for this case first. For this, I'll just simply iterate from the last. What I'll check is if my S1 of I if S1 of I is less than S2 of I, I'll make my flag as false. I'll make my flag 1 as false, and I'll break. And I'll do the same thing. I'll do the same thing for the second one. I'll just have to make it S2, and I have to just reverse this condition. Okay, and I have to make it flag 2. And at last, what I'll return? I'll simply return flag 1 or flag 2. So if any of them is true, I'll simply get true. Okay, I'll try to submit it successfully. Okay, so what I'm doing is I'm doing nothing. I'm just sorting the strings, and then checking for the conditions. This is the one which checks for my condition of S2 and then S1. Okay, So I am just checking for both the conditions. If at any time my if at last both the conditions are being followed, if any of them is being followed basically, then I'll simply return true, else I'll return false. So if I just try to analyze the time complexity for this, time complexity of this, see I'm basically I'm just sorting twice. So sorting would take n log n. So I'm just sorting two strings, so 2 into n log n, and then I'm just traversing twice. In worst case it would be 2 into n. So this is what is my time complexity. And what about my space complexity? Am I using any extra space? No. So what is my space complexity? My space complexity is gonna be over 1. This was the overall solution of the question. Check if a string can break another string. I hope you guys like the solution. If you have any doubts regarding the solution, you can just ping it down in the comments. And if you like the solution, do like, share, subscribe. Thank you. Have a nice day.